Okay, so this is how you make your density foldable. Okay, you're gonna take this piece of paper just like this, and you are going to take it and fold it down like this and make a triangle. Okay, so this is what it should look like. Then you're gonna take this corner and fold it up to match that side. And then this is your final product of your foldable, which we will then turn over and glue on the handy dandy glue dots. Okay, but before you glue it in, we need to fill it out. So I'd like you to open it back up after you folded it. And I want you to go ahead, since we've learned about these two words, I'd like you to go ahead and fill in your definition of mass right now and how to find volume, both regular volume and then also describe the water displacement method to find the volume of an irregular object. So I'm going to give you a few minutes to figure that out. Okay, so this is something that you should have filled out. It doesn't have to be exactly like mine, but pretty close. Mass is the amount of matter in an object. To find the mass, place an object on a balance and record it in grams. To find regular volume, length times width times height. Okay, you're going to measure standard objects in cubic centimeters, which is cm cubed. Okay, for irregular objects, you're going to use the displacement method to find the volume. Description of water displacement method is to fill the graduated cylinder with a measurable amount of water. So that's going to be your initial volume, like we talked about. Place the object in the cylinder and observe how much of the water is displaced or pushed up. Subtract the first water level from the new water level, which is that final volume, which we practiced. All right, after you've made sure those are all correct, let's go ahead and fold it down. Okay, so this is back to the foldable, and you're gonna fill in the outside of the foldable. Okay, so yesterday we learned about density with our pencil lab and our orange and all of our floating objects and their buoyancy. So go ahead and tell me what density is defined as. Okay, and then these blanks you're gonna put, it's defined as mass per unit of volume. So we are comparing the mass and the volume of an object to figure out its density. Okay, go ahead and tell me how density is calculated right here in this space. Remember, density is calculated by dividing the mass of the object by the volume of the object. Go ahead and write that out in words. Okay. Here are the units of measure for density. So we're going to fill in our units of measure for density. For solids, since we're comparing mass to volume, we have to label our densities as gram per cubic centimeters. We're going to label our liquids grams per milliliters. And we're also going to label our gases grams per milliliters. So those are all of our density labels, units of measure. Okay? And then finally, when you fold it up, you have this nice, neat foldable that helps you remember that density is the mass divided by the volume. Okay, I want you to turn back to your density lab that we did on Tuesday, where you had the penciled orange and the peeled orange, and where we found the density of all these objects. We are going to go back and add from our mass lab of last week and our volume lab of last week. I would like you to go and find 5 of the objects from the mass and volume lab. You're going to fill in the name of the objects, and you can choose, I put cube and Lego, but you can choose from the mineral sample, the hex nut, the bowling pin, whatever you want to choose, but choose 5 of those objects. Okay? You're going to transfer over their mass from those objects, the volume of those objects, and then I want you to calculate the density of those objects. Remember, you learned that density is found by dividing the mass by the volume, and it's labeled gram per cubic centimeters or grams per milliliters. It's how you would label all of these, because we need to label all of our numbers. All right, all of your numbers should be labeled in the mass and the volume also. No calculators, you need to be dividing these numbers out. I am gonna go over how to divide a decimal right now, just in case you've forgotten how to divide decimals. So here is my example of how to divide decimals, okay? If my problem is I'm trying to find the density where the mass is 0.16 and, oops, scratch that. The density is 8. I'm sorry, the mass is 8 divided by the volume, which is 0.16. I'll get it right one of these times. All right, so if I'm dividing this problem out, I have to know how to divide this without a calculator. So you're gonna put this guy on the outside and put him up under the house, or however you learn to divide numbers. But we've got to get rid of that decimal on the outside. So we are going to move him 1, 2 spaces, and now he's here. But to do that, we also have to move the decimal behind the 8 2 places. So now our new problem is 16 divided by 800. All right, we know that 16 can go into 80 5 times. 5 times 16 is 80. So then 16 cannot go into 0. So my answer is the density of this object would be 50 grams per cubic centimeters. And again, that's just to review how to divide decimals, okay? So hopefully you know how to do that, but that's just a review. So I need you to go back and fill in the objects, fill in the mass, fill in the volume, and calculate the density of these objects. Then I want you to tell me, are they going to sink or float on each one of these? All right, and as we learned yesterday, remember that the density of water is 1 gram per cubic centimeter or gram per milliliter, okay? So anything that's less than 1, is going to float. And if it's more than 1, it's going to sink. The next thing I want you to do is take out this calculating density little booklet, and I'm going to have you solve these 6 problems, and then I will give you the answers in a few minutes. So I want you to remember the formula that we learned. Density equals mass divided by volume, okay? And you're going to use that formula in most of these problems. So I'd like you to go ahead and spend a few minutes working on them, and then I'll come back with the answers. You could just wait for me to give you the answers, but then you're not learning. So I'm going to go ahead and trust that you're going to work through the problems and then check yourself. Okay, so here are the answers. Hopefully you work these out by yourself. In this first problem, the mass was 10, so density is mass divided by volume. The 10 divided by the volume of 5 gives us the density of 2 grams per cubic centimeters. For the second one, they gave you a mass of 24, so that goes on the top, divided by the volume of 4 milliliters, which goes on the bottom. Remember, mass divided by volume, and your answer is 6 grams per milliliters. For the third one, you did not have to use the density equals mass divided by volume, because you were just finding how much, when they put a marble in, how much was the water displaced. So hopefully you remembered that. So if it increased to this, that's going to be our final volume. This is our initial volume of 35. So when you subtract those, you should have gotten 14 cubic centimeters, or you could have labeled it 14 ml, remember. All right, number 4. Okay, small rocks, 6 grams is the mass, okay? The volume is 20 milliliters, is what it, that was the initial volume, and it rose to the final volume. So this one was a little tricky, okay? They gave you 2 volumes here, so you had to remember that you have to find that overall volume, the initial versus the final. So right here, if you did 23 divided by 20, you found that the volume you needed to use of the rock was 3. So when you divide this mass, 6 divided by 3, you get your 2 grams per cubic centimeters. On this one, which substance will float on the water? They gave you all these different densities, and then you had to choose which one you think would float. And remember, less than 1 will float. So here's your answer. C would float because it's 39 hundredths of a gram per cubic centimeters. And then this last one, the object has 18 mass grams and its volume is 2. When you divide it, you get the density is 9. Okay, one last thing I want to show you, and if you'll do this in your journal just next to your density lab from yesterday, I want to show you some ways that this triangle can be used and manipulated to solve for other things besides density. Okay, so we know that density equals mass divided by volume. Well, sometimes we're not asked to find the density, we're asked to find one of the other parts of this equation. So remember, when you're writing this in your triangle, always start here, density equals mass divided by volume. So that's how it goes, just like that in the square. So it's just, in the triangle. So it's just kind of like you drew a triangle around it. Okay, then we separate the bottom. All right, I'm going to change color so that you can see. We just did. Density is mass, and I put my little division sign right here, divided by volume. All right, we also put a division sign here. Okay, and then between the two at the bottom, we always put the multiplication sign. And we're going to use this triangle several times this year. All right, so this is how we use this triangle. So basically, if we had a problem where we were actually given the density of an object, so say the density of my object is 4 grams per cubic centimeters. And I'm also given the volume of the object. And the volume of this unknown or given object, volume is 2 milliliters. All right. So in this, they're asking me to find what is the mass of this object. All right. So to use this triangle to find the mass, this is what I like to do. When we were solving for the density, I like to cover up the D so that I see that it's mass divided by volume. But in this case, we're solving for the mass, so I like to cover up the M, and now you can clearly see that to find the mass, I multiply the density times the volume. So pretty easy on this one. Here's my density, here's my volume. So my mass is going to be 8 grams. Remember how we label mass. Okay, so pretty easy on that one. All right, so let me show you one more example. So that's to find mass. So now we're gonna solve for volume. So if I give you an object, or I give you the measurement of an object's density to be, density is, let's do 16 hundredths of a gram per cubic centimeters, all right? And I'm gonna give you the mass too. The mass of that same object is going to be 8 grams. All right, so now this time we're gonna find the volume. What is the volume? Okay, so again, this time they're asking us for volume. So I'm gonna look over here at my little triangle. I'm gonna cover up the V, and you can see that for this one, you divide the mass divided by the density. Okay, so remember, it does matter which number you put on top when you're dividing, because they come out to be different answers. So if I put 8, so if my problem is to find volume, I'm gonna divide mass divided by density. So my mass is 8, and my density is 16 hundredths, okay? So do you think that if I would have written it like this, I would have gotten a different answer? Well, you better believe it. This does make a difference. So you gotta make sure you get the numbers in the right place. Okay, so this is gonna go on the outside of my little division house. And again, this is that same decimal problem I did earlier. You gotta move your decimal 2 places, and then you gotta move this decimal 2 places. So my new problem is now 16 divided by 800. 16 goes into 80 5 times. Subtract, 16 goes into 0 times. So my answer is 50 milliliters is my volume. Okay, so just make sure you understand how to use this. When I get back on Monday, we're gonna practice using this. Make sure that you know that it does matter which number you put, because if we would have divided it out this way, we definitely wouldn't have had the same answer, okay? So to make sure there's a big difference between 2/100ths of a milliliter and 50. So you gotta make sure you get your numbers in the right part of your fraction. Now you need to work on the worksheet with a partner that Mr. Stewart is going to give you when you've completed